You're tuned in to the Dish TV, the talk show from SRI International that highlights our people, products, and technology portfolio. This series will focus on the Quantum Economic Development Consortium, or QEDC, supported by the National Institute of Standards and Technology and managed by SRI International. The QEDC is a consortium of stakeholders that aims to enable and grow the U.S. quantum industry. I'm Renita Malhotra Hora, Head of Marketing and Communications. In this episode, my guest is Luke Moritzen, CEO and founder of Montana Instruments, which specializes in cryogenic solutions for quantum materials research and technology development. I asked Luke why cryogenics is so crucial to quantum and why Montana Instruments were one of the first members of the QEDC.
We develop tools for research and development at low temperatures. And, one of a passion that we share at Montana Instruments is really to accelerate discovery. And so, with our solutions at low temperatures, you can think of that as kind of like going to the quietest spot in the universe to make measurements at the most fundamental level in materials. And so for materials, in the quantum industry, this is accessing the quantum properties of those materials. And, it's just fascinating to me that our customers are making discoveries in quantum information science and then harnessing these material properties such that one day it'll affect every person on the planet.
Why is low temperature research so integral or perhaps beneficial to discovering or researching quantum energy?
Yeah, and again, you can think of it as it's kind of like going to the place where you can make the most fundamental measurements in materials, because say at room temperature, you've got a lot of it's noise. You can think of temperature as the random vibration of the molecules. You lower the temperature and you lower the movement of materials and you lower the interactions of materials. It's a very noisy environment until you get down to almost, close to absolute zero, where now it's kind of a signal to noise thing. You can access some of the most fundamental material properties that exist and some of the most subtle signals that you could never even detect or understand at room temperature. And then beyond that, there's physical phenomena that occur at low temperatures, like superconductivity, and this only occurs at low temperatures. So the low temperatures become something that's just absolutely necessary for quantum applications.
In the notes that you sent me, you said that one of the things that you're most excited about when it comes to quantum technology is its potential for unlocking how to solve new problems. Can you explain that in some detail?
The ability to compute in a massively parallel fashion is different than what classical computing offers today. And so you have complex problems today, and one of those is designing materials, for example. And I think that's one of the most exciting applications that will come about, is being able to predict how a material will behave before it's made. And that's a very massively parallel problem. You've got a lot of interrelated outcomes that are possible, and it's something that classical computing today just has difficulty solving in any reasonable time frame. And so unlocking this potential to solve new problems like that, I think, is going to fundamentally change, not just materials, but perhaps every piece of technology that we're familiar with today, from computing to communications to sensing. And that's where I think it's going to touch every person on the planet, whether they realize it or not.
Let's talk about QEDC, the consortium that really is bringing together all of the different companies and stakeholders that are building out this supply chain. Why is QEDC necessary, and why did Montana Instruments decide to become a member?
What first attracted us to QEDC was that it brings together the thought leaders and the industry suppliers. So the thought leaders are, those with the firsthand knowledge of the barriers that exist today for advancing quantum applications, while the suppliers like us, we're designing the equipment. And because we're designing the equipment, we're oftentimes in a position to remove many of those barriers once we understand clearly what it is that needs to be solved. And so this connection has happened, and it is happening constantly, and that's going to make a really big difference. One of our roles in QEDC thus far was to lead the development of a roadmap for cryogenics for the quantum industry. Collaboratively with other cryogenics companies, we brought together academia, government, industry, and what we did there is to identify and prioritize the cryogenic related needs of QIST system development, which, when solved, will accelerate the pace of innovation and the adoption of these QIST applications. So this has really been a fascinating and rewarding process that's brought really some of the best people in the world together to clarify for everyone what the important barriers are to remove, so that we can begin to solve, the most impactful problems for the QIST community.
And as the industry develops and as QEDC becomes more mature, do you see your role, your company's role in it, stay the same, change, evolve?
You think of the picks and the shovels in the gold rush, right? We're kind of like the picks and the shovels. And the fun thing about that is we want everybody to win. There's different paradigms of computing, right? You've got ions, you've got photons, you've got superconducting qubits. Each of those operates at a slightly different temperature. But right now we're supporting all of these applications, and in different ways and at different phases of the research. So our role is we really do want every single one of them to win. And so we're a stakeholder in the larger picture of the quantum industry becoming as it evolves. And so sensing and communications, we're also involved in those applications. And the other thing that I'm excited about is, and QEDC has really done this, and the roadmap is a good example, the cryogenics roadmap is a good example, is where it brought together even the different players in our industry, which you normally would call competitors, right? And, we got together and said, you know what, this is so big that not one of us is going to solve this. So let's come together, let's collaborate. And there is an abundance of opportunity here for all of us. And so let's collaborate, let's share, and let's move forward together and faster. And so, and let's support this evolving quantum industry as it evolves. And so the collaborations and the dream teams that are forming out of this are just really exciting for us as well.
What would you say is your outlook for the quantum industry in QEDC and your company's role in it over the next couple of years, let's say?
We have big problems to solve. Not just at the cryogenics level, which there are some significant challenges for us, and that's very exciting. But the quantum industry itself has a number of very difficult challenges and barriers to remove. Error correction is one of those. Cryogenic components, just electrical components, how you get signals in and out of the cryostat. There are many things that are going to need to be solved by many different players in the industry. So this is going to be a decades-long adventure. And I think it's really significant for us as a team to know that, the work that we're doing every day is a part of something that is very significant and will affect generations to come.